All right, good. Welcome, everybody. Good morning. My name is Eldon Christensen, and I'm a PM on the Failover cluster development team. And with me is Simon.
Hi, I'm Simon Perriman. Check. Hey, Simon Perriman. I'm a technical evangelist, and I'm a former PM on the cluster team under Eldon. He used to be my manager. I've recently switched roles. And we both decided to present to you today because we like to act, we like to follow the whole cluster mentality, have high availability, redundancy. So if Eldon crashes, I'm here to take over the presentation for him.
We've each done this presentation separately a couple times, and this is the first time we're doing it together. So our plan is we're going to have a lot of fun. We're going to try to be dynamic, and so we hope you guys enjoy it. Let us know in your feedback if this works for you. If this doesn't work for you, it's actually good feedback. If we should never do this again, or if we should try doing this again. So, all right. So the agenda here. So we're going to be talking about planning a highly available your virtualization environment and all the different things you need to think about when planning your environment. So thinking about things like, understanding what do I need for storage? What do I need for my servers? What do I need? What is live migration? What is cluster shared volumes? What OS SKU should I be installing? And then what are some of the different configuration options I should be thinking about when making highly available virtual machines? All right, so the first part we're going to talk about is planning your highly available model. So failover clustering is kind of the infrastructure that enables your private cloud when using Hyper-V with virtualization. So it really enables VM mobility, where you have a set of servers, and VMs have mobility where they can move seamlessly across the set of servers. And so it enables you to update your core OS, right? So if you want to patch the host operating system, you can do that you can live migrate and move all those virtual machines off of the host OS if you need to do hardware maintenance or software maintenance and move everything off. And it gives you a lot of flexibility, and it also gives you resilience. So one of the things about virtualization is that when you're consolidating, you're going to be taking 20 servers and you move them into VMs and you stick them on top of one physical server. Well, now if you have that motherboard crash on top of that one server, you don't just lose one server, you lose 20 servers. So high availability becomes very important when you start talking about virtualization, because the hardware failures can actually have greater levels of impact. So now with the highly available environment, then your virtual machines will start over on another machine in the event that you lose a server. So there's a couple different options to think about when you're doing host versus guest clustering. So host clustering, let's talk about that first. So host clustering is where you're clustering the host operating system, where the cluster service is installed in the parent partition, and you have virtual machines which are made highly available. And virtual machines can move from host to host to host. So that's host clustering. And then you can make any application highly available by placing it inside the virtual machine. And if that virtual machine crashes, it will start over on another machine, and you can also live migrate and move those virtual machines around. The secondary model is called guest clustering. And what guest clustering is where you install the cluster service and you make the cluster inside of between two virtual machines. So the real value of a guest cluster is, think about SQL. So today maybe you run SQL on a host cluster on your bare metal, and you have the cluster service to make it highly available that monitors your SQL instances. And if one instance fails, it will go and then fail over that SQL instance to another server. Guest clustering will achieve exactly that, but in a virtualized environment, where if you need to patch the guest operating system, you can then move a SQL instance from one host to another one. So back to host clustering. So host clustering is I know Simon hates this analogy, but I love this analogy. This is kind of putting all your eggs in one basket. So you've got your 20 servers, you consolidate on top of one, and it becomes a single point of failure. And that if the host crashes, then virtual machines will move to another machine. And it really gives you zero downtime. Live migration will give you zero downtime for clients if you need to move those virtual machines somewhere else. And host clustering, as I was talking about, it gives you two real attributes, two real wins. One is application health monitoring. So if you're running SQL inside of this virtual machine, if SQL were to crash or become unresponsive, if you just have a virtual machine being monitored by clustering, it won't detect that. So guest clustering actually gives you application health monitoring, that you're monitoring the application within the VM. It also gives you application-level mobility, right? That you can fail over that SQL instance from one VM to another one in the event that you need to patch the guest operating system. So it gives you two attributes there. So thinking about just from a health detection perspective, what's the value of each one that it gives you? So what will they protect you from? What kind of faults? So if you have a hardware failure, both host and guest clustering will protect you from that, right? If the host which the VM is running on crashes, if you're using host clustering, that virtual machine will move to another host. If you're using guest clustering, the application will move from one VM to another one, which can be hosted on another host. And if you have some sort of a parent partition failure, some sort of software failure, both will protect you from that as well. If you have a virtual machine failure, if your VM crashes or bug checks, both will protect you from that in the sense that with guest clustering, again, the application will move from one VM to another one. And with host clustering, clustering will detect that that VM failed and will restart that VM either on the same host or a different host. And from a guest OS perspective, they will both protect you from that. So with host clustering, you can actually turn on health monitoring to monitor not only the state of the virtual machine, but also the operating system within the virtual machine. So if the OS within the VM were to hang or blue screen, at the host partition, the resource DLL will actually detect that, and then we'll go and fail over that VM. Now the last attribute which guest clustering brings you is that application failure. So if you have an application level failure, a host cluster will not detect that, and a guest cluster will. So these are just pros and cons of the different deployment models and thinking about it. So here's just kind of the quick recap of it. Host clustering, VMs move from host to host. Guest clustering, apps move from VM to VM. That's the big attribute there. Host clustering will let you get zero downtime because you can live migrate those virtual machines around. Where guest clustering, it really depends on the application. SQL, for example, if you fail over SQL, there is a little downtime associated with that. So can I combine the best of both worlds? Can I stack like a cluster on top of a cluster? And the answer is you can. It's a little bit complex, I'll admit. It does get a little bit more complex, but you could, in fact, have a virtual machine which is made highly available on top of a host cluster, which in then turn you make a guest cluster of the application layer between the two virtual machines. It's a little more complex, but it gets you kind of the best of all the worlds, right? In the sense that you can now move VMs from host to host with zero downtime, and you can also, if you need to patch hosts, and then if you need to patch the guest, you can move applications around, and you have application mobility to move applications around from VM to VM. Another common question is, can I mix physical and virtual in the same cluster? And the answer is yes. So if you wanted to have one machine, which is a physical hardware box, and then your secondary machine, which is your passive node, which sits there doing nothing 99% of the time, you can do that as well. So that only in a failure condition will you fail over to the virtual machine. That's also fully supported. I call this kind of a consolidated spare. If you were to kind of like expand this diagram out and think about that if I had multiple clusters where my active nodes were on bare metal, and then the passive nodes were all in VMs and they were stacked on top of the same node. So that way you don't have to have one spare server sitting there for each and every single cluster. You could have one hosting multiple virtual machines which are all spare nodes to different clusters. Does that make sense? So guest clustering on top of VMware. So can I do, so a lot of people are using VMware, right? We're telling you about use Hyper-V. But you can do guest clustering on top of VMware. VMware actually has a doc which talks about how to do guest clustering on top of ESX. I've got the link there on the left-hand side with their support policy. They do have some limitations in what they support as far as what type of storage and using VMFT and things like that. So I've got some of the little screen capture of some of the considerations they have. Make sure you go read their doc if you want to do guest clustering on top of VMware. So if you want to make SQL highly available between two VMs which are on top of VMware, you can do that. And then there's also some considerations as far as from the Microsoft side on from our support policies. And so it really boils down to, with 2008 and 2008 R2, is does it pass validate? And so those last two boxes on 2008 with vSphere 4.0 and 4.1 is does it pass validate? And if the answer is yes, then it's supported. But VMware has a few considerations on what they support as far as storage types and no VMFT and DRS. Actually, I think they just added support for. So planning workloads in a guest cluster. So if you want to deploy a guest cluster, what are some of the things you need to think about? SQL fully supports guest clustering. Actually, they have a really good white paper that talks about how to deploy SQL within a virtual machine in a virtualized environment. File servers are also fully supported as well. With Exchange, there's a few caveats today where today they don't support a highly available Exchange 2010 DAG running inside of a virtual machine which is mobile. So they don't support VM mobility with Exchange HA. So if you have a DAG, you can't put it in you can't have the VM failover from node to node, and you can't do live migrations of that VM around. So that's the one consideration with Exchange. And they are actually actively working on this as well to try to change the support policy. And SharePoint as well. SharePoint can also be made highly available on top of a guest cluster as well. So it's another solution you can make highly available. So let me show you, it's one thing to talk about it, but let me show you what configuring a highly available virtual machine looks like and kind of how you set one up. So here I've got a cluster up and running. I've actually got a lot of things running on this cluster at the moment. So it's a 2-node cluster. I've got our Failover Cluster Manager snap-in up and running. So basically what I've got here is I've got 2 servers. I'm actually using the iSCSI software target as a back-end storage device. So actually let me talk about that for a second. We just actually made available recently, I don't know if you guys knew about this, but there's the iSCSI, the Microsoft iSCSI software target. It's a free download off of the web, which you can install on your servers. It's a great solution if you want to, let's say you want to do a proof of concept with clustering. You want to try it out, you want to see what it's like, but you don't want to go out and buy some expensive hardware just to set it up and test it. You just want some basic machines to set it up. With the iSCSI software target, you can make any machine, laptop, normal Windows box look like and act like an iSCSI storage target. So it's really kind of a handy solution that, like this cluster running here that I'm running doing this demo on, is just 3 standard desktop machines. There's nothing fancy. I got 1 machine that's running the iSCSI target, and I have 2 machines which are my nodes. A lot of the demos, if you go to the hands-on lab, are doing the same sort of configuration with virtual machines. They're just 3 VMs. And they got 2 machines, which are the nodes in the cluster, and the 3rd VM, which is running the iSCSI software target. So this is a really good, proof of concept, try it out, kick the tires, see what you think, play around with it sort of solution. So I highly encourage that. All right, so I was going to configure a virtual machine for high availability. So here I've got a pair of nodes. I've got some disks, which I've enabled for clusters with CSV, and I'm going to talk about CSV a little bit later. But this enables all nodes to see all disks. And then, so if I want to configure a virtual machine for high availability, it's totally integrated into our UI. So we've really tried to provide this platform for the private cloud and done some tight integration between our UI and virtualization. So within the Failover Cluster Snap-in, I can simply go virtual machines, and I can say new virtual machine, and I can launch and create a new virtual machine. Now what you notice is this is actually we actually launched the snap-in from the Hyper-V Manager. So this is the exact same snap-in you see from Hyper-V Manager. And we're just giving you this nice experience where we pull everything together for you, so you don't have to jump back and forth between UIs. So now it asks me where I want to put my VMs. And so I'm just here browsing. Actually, I should have gone a little slower there. So when you enable CSV, it enables the single namespace across all the nodes in the cluster called cluster storage. And so what we do is we build this, we create a directory on each and every node, and then under each directory, we create effectively a mount point. What is a mount point for each volume which is enabled for CSV? And if you go to any node in the cluster, we keep them consistent across all the nodes. So here I can go into my volume, and here's where I'm going to create my VM. So it asks me, I'm just going to kind of blow through this. I'm going to make this thing pretty basic. How much memory do I want? I'm not going to connect to the network. Make a VHD. And now the one thing you're seeing right there that quickly kind of flew by is we actually kind of integrated our 2 wizards. So the first thing you're doing is you're actually running the Hyper-V wizard, and then at the end we make it highly available for you. So we take all the information about the VM, and then we automatically pass it into our Failover cluster wizard, and we make the VM highly available. And here, where did my VM go? Here it is, new virtual machine right down here. So as you can see, here's my virtual machine. I can start my virtual machine. And there it's up and running. I can connect to it. I didn't put an operating system on it, so it won't be all that interesting. So there's my exciting UI for my newly created VM. But the only thing I really want to show you here is how simple it is, right? It's just a simple create a new virtual machine. We wrap all the UIs together, and that's all it takes to make a highly available virtual machine. Okay.
Thanks. Well, one of the people often say, why is this so critical? Why is clustering so critical? Really, it's one of the key pieces of the infrastructure. My favorite analogy is it's kind of like the plumbing in your house. You need it, it's critical, but you really don't want to see it. But if you don't have it, you're in the shit. So let's talk more about the failover clustering support policy. What's important here? Now, who's done clustering in 2003 or earlier? So about half of you. How about 2008 or later? Oh, most of you. That's pretty good. So a lot of you have seen Validate. Now, Validate's important. It's a whole new hardware model. It's a whole new support policy. And there's essentially two requirements to have a fully supported cluster. One, every component must be logoed for Windows Server 2008 or R2. And secondly, the entire solution passes Validate. Now, this really simplifies the whole hardware concept. If you did clustering back in 2003, you had this hardware catalog. Whatever you wanted must have mapped exactly to the catalog. If you wanted to change a NIC, you'd have to get the entire solution recertified. So it was an expensive process, not just for you, our customers, but also for product support, because we were constantly turning people away, saying unsupported. And we realized that this isn't a good approach, It's expensive for everyone. So we just completely redesigned it. You don't even have to have identical hardware. Although we recommend having identical hardware, it's not a requirement anymore. So if you want to just try out clustering for the first time, just find 3 servers, put them together, use the free iSCSI target, have a 2-node cluster, and try it out. It's pretty simple to use. Now, if you've done clustering in 2008 and you're thinking about moving to R2, all of that same hardware is going to work. Not a problem there. Now, when we look at Validate, this is really our best practice analyzer. We're going to look at all of the pieces of the cluster, not just the software level, but applications which are running in the cluster, all of the hardware, the networking, the storage. And our goal here is to ensure that you have the best solution possible. You can even run Validate before you've created a cluster. You simply specify the nodes that you want in the cluster, go try it out, so you don't have to spend this extra time building the cluster to ensure that it's going to work. You could use it as a great troubleshooting tool. I had a problem where, right before a demo, one of my clusters wasn't working. One of my nodes couldn't talk to the others. I ran Validate, and it told me that a network cable was unplugged. And so rather than me trying to troubleshoot all of the networking properties, I just looked behind the box, and sure enough, a cable had fallen out. So just a really useful functional troubleshooting tool. And if you're calling product support, they are going to require you to first run Validate, because not only will it most likely identify where the problem is, but it also includes a lot of configuration information about how the cluster is deployed. So it's going to tell the support guys what resources are running on the cluster, what's the status of the resources, are they online, offline, failed, and what properties are being used for each resource. So you can have a lot of granularity. And if you're not following a best practice, we'll even recommend, hey, you could do something to make the cluster even more highly available. So let's take a quick look at cluster validation. So we're going to jump back to the same cluster. And to validate the cluster is pretty straightforward. You can specify the nodes. If you already have an up and running cluster, it's going to select those nodes by default. And you can choose whether you want to run every test, the full validation suite, or just a subset of tests. And so maybe if you just have a storage problem, you only want to run the storage tests. Now, for the sake of time, we're not going to run everything. But you can see here we have a group of tests called the cluster configuration. And this is just going to inventory what's on the cluster. This helps product support understand how your cluster is deployed. And if you have compliance reasons to document how your cluster is created, use this report. Don't spend the extra time documenting how the cluster was configured yourself. In the inventory, we go and look at a lot of information to see what's happening with all of the services. How are they? What's the status of them? And we do this to make sure that you have consistency across the nodes. The reason why we want consistency is because we want an application or a virtual machine to behave the same whether it's on node 1, node 2, or node 16. And so by having consistent everything throughout the cluster with hardware, software, patches, you can almost guarantee that the application will run identically no matter where it's hosted. And that's really what we want to do. As we start to think about moving to this virtualized data center, the private cloud, we really want to just abstract everything that lies underneath the VMs. All we care about is the VMs and the applications within the VMs. We want to abstract the storage, the servers, the computational power. So by having this, you haven't really an extra layer of abstraction. Having identical hardware, it doesn't matter where the VM runs. When we look at the networking tests, these are just to ensure that all of the nodes can communicate with each other. You have all the right protocols enabled. With storage, we're going to test that the storage is supported in a cluster. The key requirement we have with storage support is what are called persistent reservations. This is a SCSI-3 command, and it essentially allows one node to lock a disk and to not have other nodes be able to steal that disk from it, so that we can enforce a single disk owner for a particular node. And we're going to test all of this, but you don't really have to worry about persistent reservations anymore. In about the past decade, all new storage comes supporting persistent reservations. But beyond that, with the storage, we support iSCSI, serial attached SCSI, and fiber channel.
And FCOE now.
And FCOE, that's right.
FCOE is a new one, so we just recently added support for that.
But one of the most important tests in that is we want to make sure that every disk can be read by every node in the cluster, because we want any application to be able to run on any node in the cluster. So as part of these tests, we're going to bring every disk online on every node. And so a lot of times people ask, how long does validation take? If you're just doing a few basic tests, maybe you have a 2-node cluster with 2 disks, it's going to take a couple of minutes. But as you start to scale up, you have more nodes in the cluster and more disks. The time it takes will scale exponentially. And it could even take a couple of hours to run validate, simply because we're testing every disk against every node to ensure that you have the highest available solution possible. Now, I'm just going to quickly select one of these tests in the system configuration. We're going to make sure that we have all the same update levels on all of the nodes. I click Next. I get a confirmation. And it's going to go and look at both of these nodes in the cluster and see which patches I have on them. Now, anytime that we do an operation on the clusters, anytime we run a wizard, such as creating a cluster, adding a new highly available group, changing the quorum, we're actually going to generate a report for you. And this just helps you understand what's changed in the cluster. Maybe you have multiple administrators. And so this just keeps track of them throughout the duration of the cluster. And we're going to store all of these reports for you automatically. So if you go into C, Windows Cluster, Reports, you can see all of these reports which have been saved on this cluster for the past 2 years.
And that's actually where we save all the data logs. So like the cluster log is there. When you create a cluster, that log is there. The validate report is there. So we stick everything all in a single directory. So if you need support or you need help, you can just zip up that single directory and send off, and it has all the log data in that one directory structure.
Now, here's the test that I just ran. Pretty straightforward. We see that everything's present. But let's jump to a test that I ran some time back and didn't follow best practices here. So you can see that we have green checkboxes. We have yellow bangs, which means there's a warning. And we also have a third category, which is an error. This cluster doesn't have any errors. But if you had an error, it would mean that it's technically unsupported. It means that the cluster will not function as expected. And so you need to go and fix any errors to ensure that you have a supported solution. Warnings are okay, but it means that you're probably not following a best practice. And you should go and check it out to understand more. So I'm going to jump down to one of these warnings here. And you can see that it's extremely granular in the detail. So it's looking at per resource, is this following a best practice? And it's telling me that we don't use a standard health check here. So if you browse, you can see extremely detailed, extremely helpful. So the bottom line is, anytime you have a problem, run cluster validation, and there's a really good chance that it will tell you what the problem is and help you resolve it before you have to spend time and money calling Microsoft product support. So a great utility to keep your cluster highly available and up and running. Now, PowerShell is one of the other great management utilities which we've added in Server 2008 R2. And don't get scared, but we are going to be replacing cluster.exe in our next release. It's being deprecated, so if you start working on new scripts now, do them in PowerShell. Don't put them in cluster.exe, because cluster.exe isn't going to be around for much longer. Now, if you haven't used PowerShell before, it's a little unfamiliar compared to standard scripting languages, but after a while, you're going to love it. It has a lot more flexibility, and it even has built-in help. So instead of having to go to a website, figure out the proper syntax, you could just type get help, the commandlet name, and not only will it give you the syntax, but it will give you detailed examples. It will give you links to websites where you can go and find more information, or browse using a web browser, so you have more flexibility in searching for keywords. So try it out, and it does have full support and actually a lot more functionality than cluster.exe did. You have the ability to run cluster validation, create highly available clusters or workloads, look at dependency reports, and full support for Hyper-V and virtualization. So you can easily create VMs, enable cluster shared volumes, convert standard disks to CSV disks, and update the virtual machine configuration. So as you start scripting, now's the best time to invest in using PowerShell. And throughout Microsoft, there's been a huge initiative for everyone to move to PowerShell. So don't feel that you're going to be forced to learn PowerShell just for clustering. It's going to come in useful for all of your server management. Time for you to talk about some live migration.
All right, thanks, Simon. Yeah, so the one thing is, the real kind of philosophy we've had around PowerShell is that there's so many different command line interfaces for each different product. They're kind of different. So there's this real standardization effort to try to give you a consistent experience, no matter what product you're using, what feature, what team has built it, that you don't see the org chart when you're using our command line interface. So let's talk about live migration. What is it? How does it work? Why do you care? So live migration is for planned downtime. That's one thing I just want to stress. Planned downtime. So you make a manually invoke a live migration. Live migration does not kick in like a failure scenario. If you walk up and yank the power cord, obviously there's no time for this to happen. So let's talk about what happens. So the first thing is a user manually initiates a live migration. Let me paint the scenario here. Let me paint the scenario first. So I have a 2-node cluster up and working. VM is running on node 1. I get some client out of my little laptop, which is accessing the virtual machine. Let's say it's running SQL, which is accessing SQL running inside that virtual machine. I got a VHD, which is stored out on some shared storage out in the SAN. So the admin wants to go patch the server and goes and says, live migrate. So the first thing that happens is it actually goes and it does a full copy of all the contents of memory that's been allocated to that virtual machine. So let's say you've allocated 2 gigs worth of RAM run state to that virtual machine. That's memory in memory state running on machine 1. It takes that 2 gigs of memory, copies it across the network over to node 2. And so when that first is copied. So however long that takes, while that's happening, let's say, I'm just going to make this up, let's say it takes 30 seconds to copy over all those 2 gigs of RAM memory state from one server to the other one. All the while that's happening, that client is still accessing that virtual machine, which means data is changing, right? So we track all the dirty pages and all the pages that are changing. So what happens is while we're pushing over those 2 gigs, takes 30 seconds, we're tracking all the changes. And then what we do is we go back and we say, okay, let's take everything that changed. Let's say it took 30 seconds. Now there's 500 megs worth of changed data. And we're going to push those 500 megs worth of changed data over. While that's happening, we're still tracking all the changes. And then we go back and push it over. So what we do is we keep making loops. So take the data, push it across. While it's being pushed, data's changing. Then we go over, take the change set, push that across. That's a smaller set. So maybe that takes 10 seconds. Then it takes 2 seconds. Then it takes 1 second. And so we just keep making multiple passes, multiple loops. And we kind of call this the brownout period. This is where we're pushing configuration state, and configuration state is dynamically changing. Then what happens is we finally get to a point where we get the change set small enough after making multiple iterative loops down to the point where the set is really, really small where we can do a really fast cutover. So what we do is there is actually what we call the blackout period, where technically the VM is actually, we close the connection from one machine, and then we'll actually fire up the VM on the other side, and then the client will reconnect on the other side. So sometimes I see people using like ping to monitor a virtual machine, and they'll say, hey, I see a few packet drops. And actually, it's not a very good evaluation of watching a live migration. Well, yes and no. But what you're actually seeing is down at the IP layer of seeing some packets drop. What makes live migration live, and what makes it totally seamless, is TCP. So because of the fact that we can make this cutover so fast that it's within the TCP reconnect window. And if it's within the TCP reconnect window, your client will ever notice. So your client, which is out there accessing SQL, will just do a TCP reconnect, and they will quickly reconnect to the server on the other side. And once the migration is complete, then the VM on the old machine is deleted once everything is up and running on the new server, clients are connected, we're sure it's working, then we delete the old VM. But all the way up to that, we can actually fail back. So does that make sense? Any questions about live migration? Actually, let me show it to you.
You do have one down here.
Oh, was there a question? Oh, about a second, usually less than a second. So the question is, do we support parallel live migrations? The answer is we support one live migration between any given host, target, or host. So if you have a 16-node cluster, in theory, you could do having 8 live migrations going on, but it'd be like 1 to 2, and 3 to 4, and 5 to 6. Does that make sense? Yeah, it would be serialized one at a time. Yep. So let me actually go to my machine.
Yeah, I mean, the question here was, if I want to live migrate multiple VMs at the same time, is it possible to select all of them and evacuate them serially? You can use in SystemSet a virtual machine manager, but not in the core failover clustering. In SCVMM, there's a feature called node maintenance mode. You put a node into maintenance mode, it'll serially move them all. But I mean, we get that question a lot, is it better to have lots of parallel live migrations or serial live migration?
Yeah, my kind of 2 cents on this is, so let me ask that one and address this one. Yes, it's great feedback, and it's something we're seriously looking at and working on. So let me tell you that. So I'll give you that little insight. But yeah, there's the whole philosophy of parallel live migrations versus serial live migrations. I like to think about it as the pipe off the server is only so big. Let's say you have a 1 gig interface. I mean, you guys think about copying files. If you have 3 2 gig files and you want to copy them over the network, is it going to go any faster if you go copy 3 files at the same time or if you copy 3 files serially? And I know, and so the pipe is only off the network is only so big, and there's only so fast you can get them off. And so in my mind, draining a node, it doesn't really matter if you do them in parallel and you're pushing the data across at the same time, or if you're doing them serially one after the other. In fact, remember how I was talking about how the longer the live migration takes, the more dirty pages are changing and the more passes we're going to have to make. Actually, the live migrations can actually get longer if you don't get them through as fast as possible. Does that make sense? Because you're pushing it multiple at the same time, then you end up getting longer over time. Now, I know VMware does support this, and I know I've seen a lot of people talk about how VMware gets better performance. Actually, I'll give you my jaded Microsoft perspective. And the reason VMware actually gets better performance is their vMotions are not as efficient. It's something they actually improved in VMware 4.1, so in ESX vSphere 4.1. So it'll be interesting to see if they actually get as good a value out of the parallel live migrations anymore. So let me show you what it looks like. So let's say I have a virtual machine which is up and running here. So I just can select this virtual machine. I see live migration. See live migrate this thing to node 2. And this is an incredibly sexy, and there you go. It's live migrating that virtual machine. You can see the host is currently on current owner PMR2 node 1, and it's just migrating this across. So right now it's going through the brownout period. It's copying that data over. Goes and does a quick cutover. Bang, there we go. So I just moved my virtual machine from one host to another one, and now it's running on node 2 with no downtime. So that's the experience. And again, the more memory you have, the more active the VM is being changed. This one wasn't doing a whole lot, the longer it will take. But that gives you a little feel.
So time to talk about cluster deployment. which host OS should you choose? There's really 3 host OSs which support clustering, and there's a huge range as far as the feature set contained in each of them. So who here knows about Hyper-V Server? Oh, that's pretty cool. You know, each time we do this, more and more people raise their hands, so that's good. So Hyper-V Server is a completely free OS SKU. You could go download it today. But there are some limitations with it. It does support failover clustering. It supports 16-node clusters, cluster shared volumes, live migration, all of these core high availability and Hyper-V features. But it doesn't come with all of those other features and roles which regular servers do. So you don't have DHCP. You don't have a file server with it. It's simply the core host with cluster support. Now, since it's free, it does not come with any licenses for virtual machines themselves. So you get this host layer for free. But whatever runs inside the guest VM, you still need to get that licensed. Now, trade-offs here is, as you look at Enterprise or Data Center Edition, the other SKUs which support clustering, you get some licenses for the guests themselves. However, you're paying for the host. So first of all, failover clustering is not supported in Windows Server Standard Edition. It's a bonus feature, an upsell feature, so you need either Enterprise or Data Center with the full Windows Server SKU. But if you get Enterprise Edition, you get that license for the host, and then you get 4 licenses for VMs. So you get 5 total licenses. If you buy Data Center Edition, you get that 1 host, 1 guest, 1 license for the host, and unlimited licenses for the VM guests. So when you're starting to plan and think about this, you want to evaluate how many servers do I want to virtualize. But not just now, think in the long run. Think in 3 years, 5 years. Am I going to continue virtualizing my infrastructure? If you are, and you don't know how many servers you're going to be running in the VMs, it probably makes sense to go with the Data Center Edition. You're not bound by any licensing limitations. Now, there is a big, significant monetary difference between the SKUs. Of course, one is free. One you get licensed by the server. The other you license by the CPU. But if you just want to try out clustering for the first time, as we've mentioned, the iSCSI target is free. And now the Windows Server Hyper-V Server host OS is free. So you can actually go and download the products today, the free iSCSI target, Hyper-V Server, put 2 nodes using the Hyper-V Server, 1 node with the iSCSI target, and you could get a completely free cluster today. Just download it, try it out, and it includes all those great things like validation as well. When we look at the other considerations around server hardware, we want to ensure that you have processor compatibility if you plan to do live migration. This means that all of the processors must be Intel, or all of them must be AMD. You will not be able to do a live migration between an Intel and an AMD. But the clustered validation wizard is going to test this and make sure that they work. Now, it's recommended that these processors are at the same stepping level as well, just to ensure better performance and better processor compatibility. But it is not a hard requirement. You can actually go and change the properties of a VM and select migrate to a physical computer using a different processor version, and it's actually going to support live migration between processors at different versions. But once again, all of them must be Intel, or all of them must be AMD. And you can even go and download this little wizard for free, and it's going to go and test all of the processors in your cluster and tell you up front, is live migration going to work? Or, well, you need to go and turn on this compatibility mode. When we start to look at networks, a lot of people stress that, hey, you have a lot of things going on in your cluster. We have a lot of cluster communication going from one node to another, to the VMs, to clients, to storage, to backup. How many networks do we need? Well, the absolute minimum is 2. We want to have at least 2 of everything in your cluster. When you think about high availability, beyond just the failover clustering piece, you want to think about redundancy throughout the entire infrastructure. No single points of failure anywhere. And so this means you need at least 2 servers, 2 networks, 2 NICs, redundant storage. But beyond that, you want to think about having redundant switches, redundant internet connections, redundant power supplies. So have at least 2 of everything to eliminate all these single points of failure. So absolute minimum number of networks you need is going to be 2. One of these networks is going to be used for all of this internal cluster communication, so for the nodes to be speaking to each other. And then the other network is going to be used for the clients to connect to, our public network, and to manage the virtual machines. Now, 2, as we said, is the absolute minimum, but best practice, you're probably going to want to have 4 networks. The first network is going to be this public network again, so it allows clients or applications to access the VMs that you have up and running. You want another network for all of the internal cluster communication. So this is all of the nodes health checking each other, checking that they're alive. And this is also for cluster shared volume traffic. You want a dedicated network for live migration. And this is probably going to be the thickest network. And the reason for this is we want live migrations to go as fast as possible. And they are very network intensive because we're just trying to force as much memory through a pipe as quick as we can. Now, you have to think about, if we're flooding a network, what other type of traffic could that impact? And one thing that you have to be wary of is making sure that this doesn't impact heartbeat traffic or cluster health checks. If you're flooding one of your networks with live migration traffic, and you're trying to send these health checks to that same network, they may not get through. If you miss too many health checks, this could actually trigger a false failover, because one node could think that the other node in the cluster is unresponsive or down, and it can trigger moving VMs or moving other applications between the node. So you really want to make sure that you isolate your heartbeat network from your live migration network. And with this live migration network, have it dedicated, make it the thickest network possible so that you can get the most traffic through it as quick as you can. The 4th key network is for actual management of the guest OSs themselves. So for the Hyper-V administrator to come in and actually tinker with how all the VMs are running. If you're using iSCSI, iSCSI communicates over Ethernet through standard NICs. So if you're doing iSCSI, you want to have a dedicated network for the storage traffic as well. Storage traffic, again, it could be pretty intensive. It can use that whole network bandwidth. So you really want to isolate that, keep it by itself. And there's a best practice out there that if you're using Data Protection Manager, they encourage you to use a dedicated backup network as well. So this makes you think, wow, I have a lot of networks. How can I say what each of them is used for? And we actually have a feature in 2008 R2 called Network Prioritization, which allows you to go and rank all of the networks in your cluster and kind of assign a use for each of them. The way network prioritization works is once the cluster comes up, we go and we look at all of the networks that we see throughout the cluster, and we detect whether there's a default gateway on them. If there is a default gateway through that network, we say, hey, this is going to be a public network because we're allowing external people to connect through this network. And so we kind of put our public networks kind of on one side, and we say, you know, those should be assigned just for the public. We don't want to use any internal cluster communication going over them. Because once again, if public traffic is flooding our internal cluster communication networks, we could miss heartbeats. We could get false failovers. So we're going to separate all of the public networks. Those networks that don't have access to a default gateway, we say these are the private ones. These are going to be dedicated for the cluster use, for CSV, for live migration, or other functions. And so you can go in there, you can rank the networks, and you can really say which each of these is going to be used for. You can look at the properties of the network and specify which are assigned for live migration. So you do have flexibility in prioritizing the use for each of your networks. When we look at the storage planning as well, 4 different supported types of storage now. Fiber channel, serial attached SCSI, FCOE, and iSCSI. All of these work fine, all fully supported, so long as they pass the validation test. So really the biggest trade-off we see is cost versus performance. If you're going with fiber channel, generally it's a high-performance network, a lot of fast traffic. So it's great if you do things which have a high requirement for IOPS, such as if you're running a lot of SQL servers inside VMs. You want that fast performance to your network to make sure that you don't have any latency in the application. But fiber channel is generally more expensive. iSCSI, on the other hand, it's almost free. You don't need a dedicated SAN. You just simply have another box, and everything communicates through Ethernet. So it's incredibly cheap, But since it doesn't have this dedicated network, dedicated HBAs, it's often not as performant as Fiber Channel. Serial attached SCSI sits somewhere in the middle. So a lot of it's just the trade-off, do I need this high performance versus what's the cost of my network? And you can also use third-party replication to copy data between one node to another. So having this dedicated storage network really is no longer a requirement. But the key thing that you need to keep in mind is that all of the nodes must be able to consistently access the data. So node 1 needs to be able to see the same data as node 5. And we always see replication used if you have a multi-site cluster or a disaster recovery configuration. Now, multi-site cluster, it means that you have some nodes in one data center, some nodes in another data center, so that if there's an earthquake, a flood, some other negative impact that takes down an entire data center, everything can fail over to that secondary data center. But we need to make sure that we're replicating the data from the first data center to the second data center so that all of the information is available on both sites. The next big planning consideration we look at, especially around virtualization, is thinking about density. How many VMs can I pack onto a single host? Now, as we move to this whole virtualization move it to the virtualized data center, it's all about consolidation, moving from these poorly utilized servers to dense servers that are running at high performance, high capacity. And with failover clustering, we support 1,000 VMs per cluster. This means if you have a 4-node cluster, you can have 1,000 VMs. So if you have 32 servers, you can have 8 clusters, each running 1,000 VMs. That's 8,000 VMs across 32 nodes. So we actually have much better density than VMware. Now, you could go and deploy them across any number of nodes, but there is a limitation of having 384 VMs per server, Hyper-V limitation. So when you're thinking about capacity planning, don't think that every node in your cluster can run 384 VMs, because if one of those hosts crashes, it needs to be patched, those VMs that are running on it, they must be redistributed to the other nodes in the cluster. So always think about with this planning that if I don't have a node, do I still have enough capacity to handle the VMs that it was hosting? So if you really want to push the limits, you can have 1,000 VMs across 4 nodes. So that would be 333 VMs for each of the nodes. This way, if one of my nodes crashes, those VMs, that's 250 VMs across the 4 nodes. If one of those nodes crashes, those 250 VMs will spread across the remaining 3 nodes, so you still have 333 VMs. You still stay in support. Question in the back here. The question is there a limit of VMs per CSV? I'm actually going to get to that on the next slide, so it's a great question. So I already have the answer for you. Now, the next thing to consider here is the number of virtual processors per node. So you've packed all of these VMs in, but you also want to think about how are my virtual processors functioning. And we support up to 512 virtual processors per node. And so the ratio that we have here is a 12-to-1 ratio of virtual processors to physical processors. And when we talk about virtual processors, we also consider threads being a virtual processor. So if you have a multi-core system that's multi-threaded, you could actually have multiple threads per core, and that still stays within the limitation. So as you calculate how many virtual processors can I have on my host, you multiply the number of physical processors by the number of cores, by the number of threads, by 12. And this will tell you how many virtual processors you have. Now, realistically, we haven't seen anyone in production come to this high level of utilization in the cluster.
That's actually kind of interesting. How many people, I just want to ask, how many people have more than 100 VMs per server today? Like, show of hands. Okay, how about more than 1? Okay, we got 1. So how about, what? Okay, and so that's fine. VMware or Hyper-V, I'm just curious how many people are doing today. How about more than 75 per node? All right, a few more hands. How about more than 50? Okay, getting more, and then let's say more than 25 or greater. Most everybody else around there. So it seems like the sweet spots are kind of down in the like 10 to 25 range. Is that kind of a general nods? Is that what most people are doing today? Okay, just curious, just getting kind of a general feel.
Yeah, I mean, I think, really the message on this slide is we could support as many VMs as you could put on there in production. You shouldn't really have to worry about these limitations anymore. If your service could handle it, clustering can probably handle it too. Now, back to your question. What about CSV support? How many VMs can I run on a node? Well, cluster shared volumes is the new distributed access file system for Hyper-V, which came out in R2. A lot of people call it a clustered file system. Technically, that's not quite accurate because we don't have a distributed lock manager, which is a requirement in industry standards. But neither does VMware FS.
VMFS isn't a clustered
That is also not a clustered file system. But functionally, these are the same. They allow...
Symbolic, you could argue, is a clustered file system, or polyserv is a clustered file system.
Well, essentially, they allow VMs to run on any node, and they can all access the disk at the same time. So when you did clustering in the past, 2008, with virtual machines, a lot of people really limited themselves to just having one virtual machine per LUN, so that if that VM had to move, you'd move that LUN with it. And so it made kind of a LUN management nightmare. You're really limited in carving these isolated LUNs out. And so with CSV, we've really got away from that limitation. You're no longer just bound to having this one VM per LUN. You could just put as many VMs on the LUN as you want. And when you plan this, we don't have any limitations, but it really comes down to what your storage can handle. How many IOPS a second do you actually need going to that storage? So maybe you run 4 VMs. They all have SQL databases in it, a lot of intensive I/O writing. You're probably going to really limit the number of VMs that a single CSV volume can host. Now, if you're doing something like VDI, you have thin clients, not a lot of intensive disk I/O, go put on 50, 100. But just make sure that when you're testing this before you go in deployment, that you're using simulated production workloads. So you want to simulate, real workloads running in these VMs to figure out how many VMs a disk I can support. But generally, your storage vendor, they're going to test this out. All the major storage vendors support cluster shared volumes. And in fact, all of the storage that you had back in clustering in 2008 will work as a CSV disk in 2008 R2. There aren't any special requirements. CSV just has to support NTFS. So key message here, when you're planning, try it out with production workloads. Not just to see how many VMs you can have a disk, but just with the whole capacity planning in general. How many VMs can I run per host? And this will really figure out your density.
Let me speak a little bit to your question, so go back for a second. So the thing, VMware has a lot of guidance on how many VMs you can put because of the way they do their metadata updates and they do their locking of the volume. So the one consideration to really think about, we do all of our locking and metadata orchestration server side, so we don't have any of those considerations that you need to think about from how many VMs can I put on it. I know they changed the way they do locking in ESX 4.1. So, but another thing to think about, really the real factor to think about is how many VMs you can put on your CSV volume, is that in the past, the server was really the bottleneck in how fast you could get I/O off of a box and hit a LUN. This is, so unless you did crazy things like put in 4 or 8 HBAs in a server, you really couldn't get the I/O off the box fast enough that the storage array couldn't keep up with it. With CSV, now think about it. Instead of having one server hitting a LUN, you've got 16 servers which are simultaneously streaming I/O and hitting a LUN. So the recommendation really comes back to your storage vendor, and what does your storage vendor recommend? And it totally depends on the vendor, and it'll actually depend on the family of array. I'll go talk to some storage, if you have one of the newer arrays which has tiered storage, a lot of those vendors are going to say, I don't really care, right? Because a LUN is just an abstraction, a virtual abstraction from the storage array. Older storage arrays, right, you had to think about, well, I need this many spindles to satisfy this many IOPS and this sort of a RAID set, and you had to do a lot of planning, right? And if you have an older array that you need to think about those sort of things, you'll need to be thinking really hard about how many VMs you put on a CSV. If you have one of the newer arrays, right, they're going to say, well, I don't really care. We're going to intelligently handle placing the data on the spindles. We're going to intelligently place with tiered storage, and they're going to say, I don't care if you have 1 LUN or 20 LUNs, it doesn't make a difference. So the story is going to vary greatly depending on your storage vendor.
Thanks for that, Hand. Now, final part of planning I want to talk about is Active Directory considerations. We do have a requirement that all of the nodes in cluster are part of a domain, the same domain. And they must all have access to a writable domain controller. So this means that you cannot have some nodes in a branch office with a read-only domain controller. All of the nodes must actually be able to write to that domain controller. So if you have multiple sites, you want to make sure that you have a domain controller at each site. Now, a lot of people say, I just want to build kind of my private cloud infrastructure, put everything on my nodes. Can I put my domain controllers on my nodes as well? You can, but again, you want to make sure that you have at least 2 domain controllers to avoid this single point of failure. If you have a domain controller on one server, you lose that single server, you're going to lose your whole cluster, your whole environment. Because when a cluster comes online, it will actually write to Active Directory, and it has a dependency to speak with Active Directory to bring the cluster up and to bring any resources on that cluster. And this is a challenge because some people will go and put their domain controllers inside virtual machines which are on the cluster. Now, let's think about what happens if the cluster shuts down. Well, the cluster needs access to a domain controller to start the VMs, but the domain controller's inside a VM. So you're kind of in this chicken and egg situation where you can't start the cluster, can't start the domain controller, can't start the VMs. So the recommendation is to put at least one of these domain controllers on the physical bare metal so that we can always make sure that we can access the domain controller and always bring it online. Now, I also get asked, could I go and put a domain controller inside a non-clustered VM, which is actually on a host? And the answer to that is yes. If you have a VM which is not part of the cluster, but on the same host, it does not have this requirement to speak to Active Directory to start that single VM, since it's not part of the cluster. So that would be a supported solution as well. But generally, having it on bare metal is going to make it come up faster, which means it's going to make your clustered VMs come up faster. So in the event of the crash, you can bring all of your services back online as quick as possible. Now, your turn to talk about some of the best practices when you deploy these VMs and the failover policies.
All right. So keeping VMs off the same host. So I'm just going to go through some of the different properties, configurable properties that you can set for your cluster. So main point of this stuff is that maybe you'll care, maybe you won't, but these are just things so that you know that if you want to accomplish these things. So let's say you want to keep VMs off the same host. We call this anti-affinity, right? That you want to keep VMs off the same host. Let's say you have a guest cluster. You probably want both of those VMs in the guest cluster not to be running on the same host in case that host crashes. Same thing with like your domain controllers. You probably don't want your domain controllers all running on the same host, so if that host crashes, all your VMs go away, all your domain controller VMs go away. So you want them to be on different nodes if possible. So we have an attribute called anti-affinity class names, which is an attribute you can set for a virtual machine, which will tell clustering to say, if possible, try to keep these VMs off the same host. If there's no other host available and there's no other way to bring it up, availability is most important, still bring it online on that node. But the goal is try to keep these things away from each other. So we also have a concept of what we call auto start. Think of it as if you guys are familiar with what VMware has, they have priority. They have high, medium, low, and disabled. We basically have the concept of high and disabled. So this is our concept of disabled. We use this term auto start. I don't really like it, but that's what we have today. So we're working on fixing that. So it's a little confusing. But this allows you to say a VM is disabled and it cannot fail over. So let's say you have some low priority VM. You don't care about all that much, but you still want VM mobility that you can live migrate it and stuff like that. But if the host were to crash, just leave this VM in a failed state and then you can deal with it manually. So we have this disabled concept as well. We also allow you to, let's say a cluster shuts down. Let's say you have 1,000 VMs up and running in your cluster, and you shut down the whole cluster. Now, when you boot up that cluster, what's going to happen is that traditionally, in the past, we would go try to start the virtual machines on the nodes as they start to come up. So if you don't want to try to have the first couple nodes that come up, try to start all 1,000 VMs on that node. So what we have is this thing called persistent mode. And what persistent mode does is say, hey, wait a little while, a few minutes, to make sure to give time for the other nodes in the cluster to come up. So what we do is we remember that like node VM number 2 was running on node 2, let's say. And so when node 2 comes up, we'll actually start it there. And when node VM 40 starts, we'll say, oh, we remember that was running on node 4. Let's wait for node 4 to come back up and we'll replace it back on node 4. So it's our way of saying, let's wait for the whole cluster to come up and replace everything back where it was, if you need to bring down the whole cluster for maintenance. We also have health monitoring. I talked about a little earlier that we can health monitor the OS within the virtual machine. So you'll find it here in the private properties of the virtual machine. There's a heartbeat setting. And that actually uses the integrated components within the virtual machine that we will use the user mode service running inside the virtual machine for the integrated components. We will actually heartbeat that all the way down through the virtual machine, all the way down to the parent partition. And if the operating system within the guest becomes unresponsive, maybe it hangs, maybe it bug checks, we will detect that at the host, and then we can take recovery action. We can restart the VM, we can fail it over somewhere else. So thresholds. So if you're configuring a guest cluster, one thing you may want to do is we have these thresholds for heartbeating between the nodes in a cluster. And if you're going to be live migrating a VM from one node to another one, there's this little blackout period. So I talked about earlier. Well, you may want to increase our thresholds of a guest cluster so that we don't detect those little periods where a VM is unavailable because it's being migrated. And so you can increase our thresholds just to make sure you don't have any false failures. Is kind of the key point on this slide. So dynamic memory. So dynamic memory is one of the big features which just came in Service Pack 1. So historically speaking, memory is one of the greatest resource constraints when deploying virtual machines. So we have dynamic memory in SP1, which will allow a virtual machine's memory to dynamically grow and shrink based off of its need. And you can configure priority for virtual machines, which will allow it to say, this one's more important than this one, and to get in how memory is allocated to the machines. So I just want to point that one out there. It kind of doesn't have a whole lot to do with clustering, but it's a really cool new feature that just came out in Service Pack 1. So the root memory reserve. So one of the things that we do for clustering is, which is, I should say, particularly important for clustering, is that we reserve some memory in the host partition to make sure that the host never becomes starved. That, let's say you had a node with 100 VMs fail, and we try to fail over and start 100 VMs at the same time, that starting that many virtual machines could potentially completely saturate the host partition, trying to satisfy those immediate simultaneous requests, that it can't go and start them all. So what we do is we actually reserve some memory for the host partition to ensure it never becomes saturated and that it can still be responsive. And we actually changed that. So we used to have a static value in RTM. And then with dynamic memory, we actually said, you know what, we can get smarter about how we allocate memory for the host partition. Opposed to just setting the static value and it works most of the time and we hope it works for most people, that we can actually get more intelligent and use some of the same techniques that we use with dynamic memory to also make the memory reserved for the host partition dynamic. So we actually will increase it based off of the number. For each gigabyte of RAM in the box, we'll actually reserve more memory for the individual host. By default, it's dynamic, and we'll take care of it. It's actually like we reserve 384 megs plus 30 megs for each gig of RAM in the box. If for any reason you find that's not enough, there's actually a registry key where you can go modify that and make it bigger. So my recommendation is it should be fine, and you shouldn't need to change it. But if you wanted to, you can.
Does the dynamic memory work with all guest OSs?
It only works with dynamic memory with two. It's with what guest OSs does it work with?
I don't recall off the top of my head.
It's only, I think it's Windows Server 2008 and higher. So it's it's only Windows SKU. It's only Windows, and it's Windows 2008 and higher.
The guests must be enlightened, so they must know that they have the integration components
2003
installed.
as well.
Okay. 2003 and above. So as long as you have integration components installed, it's Windows Server. I believe it should work. So 2003 above.
I just want to mention this one. This one is kind of a bug that bites a lot of people, so I just wanted to point this one out. So when using highly available virtual machines, if you use the failover cluster, so let me take a step back. Whenever you make a change to the configuration state of the virtual machine, it needs to be synchronized across all the nodes in the cluster, so that when you fail over that virtual machine, that those configuration settings are also take place over there. If you open Failover Cluster Manager and we expose the same configuration options that you see in Hyper-V Manager, and if you do it through our UI, we know that it's a clustered VM, and we do the right thing for you. And we say, oh, we know this is a clustered VM because you did it from the cluster UI, and we're going to go do the right thing for you. The Hyper-V UI has the default assumption that everything you're working with is a standalone VM, so they don't actually go and replicate it for you. So what you have to do is if you actually do changes from the Hyper-V UI, then you have to refresh the configuration to sync that state across the cluster. And you can either do that by opening Cluster Administrator and you see this More Actions, refresh virtual machine configuration, we have a PowerShell commandlet to do it. My whole message here is that if you're managing highly available virtual machines, do it from the Failover Cluster UI and don't do it for Hyper-V Manager. And if you do that, everything will work good for you. But this is kind of one of those big painful points that a lot of people kind of get bitten by. So I just want to make sure I kind of raise the visibility on that. All right, so let's talk about manageability.
So manageability, really, we're going to focus on System Center, looking at the SCVMM products. So who here's used System Center to manage their cluster, SCVMM? Oh, that's great, most of you. Has anyone tried VMM 2012? Okay, only a few. So, I mean, I'll say personally, I think 2012 rocks. It's great. It just has a lot more functionality than regular VMM or VMM 2008. So in 2008, it was all about managing the VMs. But with VMM 2012, you're managing the fabric, which includes the storage, the network, the memory. So it really gives you just a lot more functionality and gives you the ability to use a single console to not just manage the VMs, but manage this entire environment. So the beta was released a couple of weeks ago. It's a great beta. It's really stable. I did a week-long training class using only that beta a couple weeks ago, not a single problem. So try it out, start to get your feedback in so that the System Center team can take those changes and still have the opportunity to make improvements to the product. But try 2012, it rocks. It's a great product. But moving back to System Center VMM 2008 R2, we're just going to quickly cover some of the big features that they have here related to clustering. The first one is quick storage migration. Quick storage migration gives you the ability to move a running VM between different storage with minimal downtime using a single-click operation. So if you're going from a standalone server and you want to move it to a cluster, you could use quick storage migration from one cluster to another, from one standalone to another. So essentially what it does, it's going to take a snapshot of the running VM at that point in time, and after that, start creating a differencing disk. It's then going to move this core snapshot using bits, background intelligent transfer service, from that piece of storage over to the other storage. Now, while this is being pushed, the clients are still connected, the VM's still online, but the data is just being written to that small differencing disk. Now, when we want to do the switchover, we will actually have downtime. We will offline the VM and then just copy that tiny bit of data we was on the differencing disk over to the second storage device. We merge the snapshots and bring the VM back online on the second piece of storage. So rather than having the downtime of copying this huge VHD file across, we're copying that huge VHD file behind the scenes, and the only downtime is while you're copying that small differencing disk. So it gives you a lot more high availability here. Question? It is not live because there will be downtime when we copy that final differencing disk. So the VM stays online while we copy that base disk, that base image, but we do need to bring the VM offline while we copy that final tiny bit over. But since we're only copying this much instead of this much, the amount of downtime is much smaller. And we handle all of the merging automatically. We handle offline and automatically, online and automatically. So it's really kind of a single-click operation. Yes, we do actually shut down the guest OS. We do shut down the VM, but only while we're copying this piece of data, not the whole. It's a save state, thank you, yes. It's not a shutdown, it's a save state. So it will come back online much quicker as well without a full OS boot, which would be true with a shutdown. Another great feature is what's called intelligent placement. So this really helps with the planning and figuring which VM should go on which host. Intelligent placement has this nice star system. And this gives you the ability to rank each of the hosts by saying which is the best host to have this VM. So if you're creating a new VM and you want to place it on one of the nodes in the cluster, it will place it on the best node for you. If you're doing a live migration and moving one VM from one server to another server, it will pick the best server for you. So what do we define as the best? Well, it's actually customizable based on where you feel that the biggest resource bottleneck is. Is your biggest constraint in the memory, in the disk, in the network, or in the CPU? And so you can toggle these settings to say, what is most critical for my host to have? Maybe you say it's the memory. Having a lot of free memory is the most important thing for my host. And so it's going to go and look at all of the hosts, and it's going to find the host that has the most free memory and give that 5 stars, saying, this is my best host. So when I do a live migration, or I add a new VM to the cluster, it's going to automatically put it on the best host for you based on your configuration. And that's different than just using regular failover cluster manager. If you do a live migration, you have to actually go and say which of the hosts you want to move it to. With intelligent placement, it's going to go and pick the best host for you. Now, clustering in SCVMM 2012 has a lot of added features. They've realized that clustering is now a core part of the infrastructure. If you're having this private cloud, you're having this virtualized data center, you really need clustering underneath as a critical piece of the infrastructure. And so they've added a lot of high availability features here. So using SCVMM, as I mentioned before, it manages more than just the VMs. It manages the fabric, the servers as well. So you can even create clusters through SCVMM, run validate, deploy clusters using it. So when you just add all of these standalone servers into SCVMM, you could go and pick 4, pick 8, and make them a failover cluster using this single interface. So without having to jump between failover cluster manager, SCVMM, Hyper-V manager, everything can now be done using SCVMM. But since it is becoming such a critical piece of the infrastructure, it really needs high availability. If you lose your SCVMM admin console, this can really impact the functionality of your cluster, to be monitoring the VMs, to be doing live migrations, to be detecting when resources need to be moved around. So you can now make the SCVMM itself clustered, make SCVMM highly available. So if the host that SCVMM is running on fails, this host or this SCVMM service can fail over to another node in the cluster, maintain high availability. There's some great features around patching as well. One of the biggest pain points that you guys have probably had if you have a cluster is patching the host OS. It's a manual operation. You have to go to the first node, evacuate all of the VMs one at a time, do a patch, do a reboot, check for dependent patches, install those dependent patches, reboot, reboot, reboot. Then move the VMs back onto it. Go to the next node in the cluster. Do the same operation again and again and again. So one of the nicest features that I've found added in VMM 2012 is what's called Update Manager. And it gives you the ability to simply specify a baseline of patches, saying, I want these 10 patches on my nodes. You click Go, and it will go and patch every node in the cluster, doing live migration to move all the VMs around so you have no downtime for the VMs themselves, and serially go and patch every node in the cluster. So it's one of those things where you just set it up the night before, go home, come back in the morning, your cluster's patched. You haven't spent these 4 hours just doing manual failovers yourself. So as IT pros, as data center admins, this feature is going to save you a ton of time. I'm sorry, could you repeat that?
Should I wait for the Service Pack 1 to come out?
Should I wait for Service Pack 1 to come out? No, absolutely not. Try it out today. It's great. The beta's even good. Come on.
If it runs into something like a VM having an ISO file attached that, it can't like live migrate,
So the question is, what happens if we're doing update management and there's a problem with the VM, we can't live migrate it? I believe that there's a fallback that allows you to do a save state of the VM, and so that VM would have downtime. So you try to patch it, it would have downtime. Now, if you can't patch that VM at all, the options will be to stop the whole process, to say, hey, wait, pause, there's an error with a particular VM or a particular host, or to just exclude that from the patching cycle and to not move it. But by default, it'll try to just shut down the VM, keep patching the host, and then bring it back up afterwards.
Now, can the failure be transferred to email using Operation Manager or something?
The question is, can the failure be transferred to email using Operations Manager? So at the end of this patching cycle, there is a report that tells you what happened throughout the patching. It does not have any direct integration to send an email, but using Opalis, or System Center Orchestrator, or System Center Service Manager, you could go and create a workflow that would allow you to trigger an email, send an email to an admin, alerting him that there was a problem in this workflow. But there's no built-in email functionality as part of Update Manager.
And Carmen's actually the PM who drove this, and she's down in the Ask the Experts area. So if you go down there and down in the SCVM booth, there's a 2012 booth, and she's down there. So if you want to learn all the nitty-gritty details internal, she'll be happy to talk to you about it.
And dynamic optimization, this gives you the ability to pretty much do load balancing across your cluster. And this would be load balancing of VMs, not load balancing of network traffic. So when you look at all of the hosts, all of the VMs, you've gone and configured your intelligent placement to say that free memory is the most critical piece of your cluster. And so what it will do, it will continually monitor all of the hosts and distribute the workload across all of the hosts so that you don't have any hosts which are, getting high utilization, approaching memory overload, which could cause a crash. And this is a built-in function. Now, if you use System Center 2008 R2 with System Center Operations Manager, you might know of a feature called Pro Tips, which basically monitors a host, and when it starts to reach its resource utilization, it will do a live migration and move the VM from that overutilized host to an underutilized host. This is pretty much the same feature, the same concept, but built in just to VMM. So you don't have to have these integration components and set up connectors between Operations Manager and System Center Virtual Machine Manager. The final big feature is power optimization. So this is one of the pushes that we've made towards this concept of green IT. And what we look at here is during downtime, maybe it's the weekend, maybe it's off hours, some of your VMs really won't be used. And so the hosts, they don't all need to be up and running. So we can actually go and park the hosts, the cluster nodes, turn them off, and put them to sleep to save you money on power and just to maintain, keep everything up and running, but not those hosts which aren't needed. Now, once those VMs start to be used and more memory is being consumed and those hosts need to be added back to the cluster, we can wake them up, put them back in the cluster, and redistribute the VMs across all of them. So it gives you a little more flexibility in managing the cluster. It will save your data center money. It will make your hippies at your company happy because you're saving them money too, saving power. So another great feature built in here.
Your hippies at your company happy. All right. In summary, so I just want to say high availability and virtualization. When you're doing virtualization, high availability goes hand in hand. So as we showed you some of the things, we're tightly integrated. You can do live migrations. You can create VMs. You can all do it through our UIs as well. We're tightly integrated. And host clustering can really achieve you to achieve zero downtime. And System Center is a great solution, which is also tightly integrated with Hyper-V and clustering to give you complete management of the whole solution. So with that, I want to say thank you very much. We'll be happy to answer questions. We're also going to be in the Ask the Experts booth later. And so we have any questions? Yes? So the question was, can I do validate on a system with no downtime? And the answer is yes. The caveat to this is that to run a storage test on a LUN, we need to bring the LUN offline. So by default, if you run validate on a configured production cluster, we will leave any LUNs which are currently allocated to like SQL or a VM online, and we won't touch them. Anything that's in available storage, which is not being allocated anything, we will run against. Or if you manually bring the disk offline, we'll run against it. So the answer is yes, it won't have any impact.
Yeah, you'll see this little part of the wizard that says, hey, you have up and running services or applications. Do you want to shut them down? Or do you want to keep the ones that are online, keep them online so you don't have any downtime? So you do have that flexibility.
You had a question over here, yeah. So the question was around CSV, and should I have multiple CSVs broken up? So let me take my step. With CSV, we have one node which is orchestrating all the metadata updates associated with that volume. And it's on a per LUN basis. So if you had 10 LUNs, you could have them assigned by different nodes, and you can have each one acting as the orchestrator for each one. So the question was, should I distribute those out across my nodes? And should I try to keep my VMs co-located with the owner? My initial answer in the operation of the cluster is it doesn't matter. Metadata updates are incredibly infrequent, and they're small and they're lightweight, so it really doesn't matter which node they're associated with. Now, with that said, there are other considerations where that may make sense, and it really comes down to backup. And so from a backup perspective, I would say that probably makes sense to do that. So that if you wanted to back up all the VMs associated with a CSV, that you can minimize the impact by breaking it up a little more. I saw another hand over here. Was there more questions? Yeah, over there. Safe to disable the swap file for the parent partition. And why would you want to do that?
The business model is that embedded SD is becoming more prominent. And so Hyper-V embedded, we're doing boot from SAN. Boot from SAN, your page file is going to be starving I/O from your SAN infrastructure.
Mm-hmm.
So one of the considerations would be to say boot from SAN.
Yeah, that would make sense if you're doing boot from SAN. I don't know that if you had a local disk, I don't know that it's. I think it would depend on the scenario. I think if you're doing boot from SAN or something like that, it would make sense. I don't know that it would be something I would go start broadly doing in general. Does that make sense? Other questions? Yeah.
What's the difference between Pro and SVVM?
I'll take that one. So question is, what's the difference between Pro Tips and SCVMN's dynamic optimization? Functionally, not much. They do the same thing. Once they detect that one of the servers, one of the hosts is reaching capacity, it will redistribute the VMs across other hosts. The primary difference is that in the old version, Pro Tips, that required having SCVMM, that required downloading the Pro Tips management pack. You needed to set up connectors between Operations Manager and SCVMM. Whereas with dynamic optimization, it's just built into the product. So functionally, pretty similar behavior. They do the same thing, redistribute traffic, but it's just easier to configure, easier to use in a single,
nice.
In a single product.
Before it was kind of duct tape and super glued together to get a solution. Now you have a nice shrink-wrapped solution. Think of it that way.
So the dynamic optimization is actually part of 2012?
Yes, it's built into VMM 2012. It doesn't require Ops Manager. Although generally with 2012, you're just going to buy the whole bundle anyway. But yeah, just VMM 2012, don't need anything else with it.
License question. If I have that 1 year, whatever you call it, insurance, does that automatically upgrade me 2012 or I still have to buy some license for it?
The question is about licensing. If I already have a VMM 2008 R2 license, will it automatically upgrade me to 2012? I'll be honest, I don't know the answer off the top of my head. I'm not a licensing guy. I don't know if you would.
I'll be honest.
You would have to go ask the VMM team downstairs in the product booth. Sorry.
Yeah. So the question was around, how do I enable a VM to be highly available with SCVMM? And will it do the cluster integration? The answer is yes. They actually have a checkbox in their UI, which at the bottom it says, make this virtual machine
Make highly available or something.
And it's a single checkbox during the VM creation within SCVMM. And then, and if you check that box, then they will do everything that we just did through our wizard. Hyper-V Manager does not. Hyper-V Manager does not. But if you create a VM through Hyper-V Manager, then you can go into our UI and you can make that virtual machine that you just created highly available. So we have this wizard, you can go in here and say configure service or application. And then you say virtual machine. So what you would do is you would say, you create it through Hyper-V Manager, and then you'd run our wizard to make it highly available. So it can definitely be done, and then we go query. So here, I just queried all the nodes to find all virtual machines running across all these servers. And then I can make any of those those are standalone, unclustered VMs. It can be done, it's just not as smooth and clean. Yeah?
Is there a way to validate and ensure that each VMM has the same version of integration component installed on each VMM?
There is none that I know of. The question is there a way as part of validation to check whether all the integration components are consistent? That is not built into our validation tool. And I'm not sure off the top of my head if VMM 2012 is having that, but within Failover Cluster Manager, no, we do not have that. Great question. Good feedback. I mean, that's something that we'll definitely think about.
Yeah. No, it's a great point. Is that if you make a configuration change and you want to verify your storage works, maybe just leaving a small unallocated LUN just running validate is actually a really good best practice.
And
Absolutely, totally agree.
Actually, I've seen that with migration because sometimes you'll do a migration from 2003 to 2008 R2 and want to have everything up and running. But of course, you want to validate your storage because you've gone from a 2003 version to R2. So you go kick up the workloads, bring them online, and just have that one extra LUN, run validation against that one LUN. So kind of the challenge there is, for technical support, you're supposed to run full validation against all of the LUNs. But by doing this, it could give you some comfort to ensure that it's working while minimizing the downtime. Sorry, could you repeat that?
So, yeah, the question was, does VMM 2012 have storage live migration? And the answer is no. But it is something we're aware that the other guys have that we need to be seriously looking at, and we are. So
our solution is quick storage migration. So you have that little bit of downtime there with just moving this difference in disk instead of this guy.
Yep. So we have a little bit of downtime, but we're well aware that we need to do better. Yeah.
Since all the guests would have, I guess in some scenarios would have a local C drive, and now you said that through a free offering from Microsoft, you can do an iSCSI where your offered D drive would come to, I guess, 4 drives or multiple drives for a physical offering you have. Do you have a limit? I mean, for the guest, can you give it 2 sets of iSCSI offerings? I mean, how does iSCSI work from the guest perspective? You need to have like 8 drives that for storage reasons. That's a project.
Yeah, you can actually create many multiple LUNs, so there's no limitation. What's the actual initial? No, yeah, you could connect to multiple targets if you wanted to and present LUNs from multiple targets. You can have large numbers of LUNs presented off an individual LUN. The Core OS has no limitation. I forget what the iSCSI limitation is. It's like...
It's pretty flexible, yeah. You shouldn't
in the thousands,
run into
I think,
issues
so.
there.
You can use GPT disks, and then you can get larger than 2 terabyte volumes.
In one of the sessions, they said there was an OS limit because after a certain point, this manager wouldn't display additional lines as drives.
Within the iSCSI target, you're saying? Or
No, not as iSCSI, but the OS showing those targets. This manager would actually use that to set them up.
and they were saying there was an issue with iSCSI or an issue with the target?
It's the OS actually showing those iSCSI lines after a certain point in the disk manager. So you can't use, at a certain point, disk manager crashes. And it was something like ridiculous number, 500 and something.
No.
I'll tell you the person, so if you want.
Okay. No, I mean, the Core OS supports thousands and thousands and thousands of LUNs. So there's no limitation there. I don't know why.
I think it was a limitation of the lines, it was a limitation of
And the size of the
Disk
volumes?
manager.
With
disk manager.
yeah, with
Could you use PowerShell or CFD as an alternative? Did they mention that?
They said it was at one of the other sessions.
MBR is a 2 terabyte limitation. With GPT, it's 256 exabytes or.
Question over here.
I have 2 questions. First question is all the functionalities in the Failover cluster manager included in SCVML?
Question is all functionality of Failover Cluster Manager included in SCVMM? Most of it is in SCVMM 2012. You could run validate, you could create clusters, but there are going to be some features which aren't available. For example, migration. So they've kind of thought about it as what are the most common features? What are the things that most admins are going to want to do? And a lot of those features are in there. So live migration, creating highly available VMs, things like that. But of course, you have to keep in mind that VMM is focused on virtual machines. So if you wanted to create a highly available file server, you would still need to go to Failover Cluster Manager to create that file server there. So core virtualization features, yes. Other cluster functionality, generally no.
Possible owners, preferred owners. If you really want to get hardcore and tweaking some of the real fine dials and knobs, they don't expose all of those.
But we support a lot of remoting, so you can do it through PowerShell, connect it through Server Manager on that same host. So you don't need to log on to the different box. Failover Cluster Manager is remotable as well.
Second question is how does SCVML manage patches? Does it have its own patching mechanism like WSAS, or it relies on, or it works with WSAS for something?
So question is, how does Update Manager in SCVMM 2012 handle patches? Does it come through WSUS or
Yeah.
through Configuration
No,
Manager?
it will work through with the WSUS server.
WSUS.
Yeah.
Yep. So you can create a baseline with WSUS, import that baseline into SCVMM, and do a scan, see which nodes have it, and then what's called remediate, which means go and then deploy those patches across it. Any other questions?
All right, thank you guys. I know we ran a little over, but I think we had some good questions.
Thank you. Please complete an evaluation.